I need somebody help, not just anybody help. You know I need someone help. When I was younger, so much younger than today, I never needed anybody's help in any way.
Oh, hello. My name is Mr. Markarian. This video will be a review of Ionic Nomenclature. As you can tell, the ceiling fan is still here. The lighting in the room is still horrible. But hopefully the information in this video can help you. So sit back, take a listen, and enjoy the ride. The first type of nomenclature that we'll look at is known as Type 1. In Type 1 nomenclature, we're really focused on the representative elements. Now again, representative elements are families 1 and 2, which are shown here, and families 13 through 16, or you could say we're looking at the A groups, and you can see the 1A, 2A, 3A, etc. So if you have elements from these groups, remember that the elements in family 1 have a +1 charge, the elements in family 2 have a +2. Forget the transition metals, skip over to group 3A, they're +3s. The carbon family is plus or -4, it depends on if it's a metal or a non-metal. And then you get into these groups here, and most of these guys that we talk about are non-metals. A couple of them are metals. But generally we'll just say these guys have a -3, a -2, a -1 charge, and noble gases are given a 0 because they don't make ions. So with the type 1s, if we wanted to write the formula for, say, lithium oxide, we would find lithium. Lithium has a +1 charge. Oxide has a -2 charge. So when we put those guys together, we look at lithium, we write down the symbol first. I found the charge from its location on the periodic table, put a +1 there. For the oxide, we have the -2, and we just have to come up with a way to get these guys to balance out. Well, the oxide is really negative. It's twice as negative as the lithium. So for the lithium, we'll have to double it and put an Li2, and that would be 2 positive charges. And the oxide, which has a 1 here, but we don't usually write it, would be 1 times a -2. Well, a +2 and a -2 will cancel each other out, giving us a charge of 0. So the formula for lithium oxide would be Li2O. So those are type 1s. You basically just look for the charge, get the element symbol, find a way to get these guys to 0 charge, and then write out that formula. Once that formula is neutral, you're good to go. Now here's another example from the type 1 nomenclature series. Here we have an Na3N, and so when you're going in reverse, you're trying to figure out the name of this particular compound. The 3 doesn't really matter in this case because when you think about it, all of the sodiums have a 1+ charge, and all nitrides have a 3- charge. And that's why the type 1s are kind of easy. If you know the charge from the periodic table, then you understand that there has to be 3 sodiums with 1 nitride to get these guys to 0 out and be balanced. So when you name type 1s, it's fairly simple. I look up the element name. For sodium, it's Na. So I see the symbol Na, I write down sodium. I see the symbol N. That would normally be nitrogen, but when nitrogen's an ion, you cut off the end, keep the nitr part, and rewrite it as nitride. The "ide" means it is a single ion, single element ion. So that's really important. So anytime you see "ide," there's no oxygen involved, nothing combined with the nitrogen in this case, it's just nitride. Now you have to remember that nonmetals which starts with N, those guys get a name change. We change it to Ide. That also starts with an N. And then remember that all the nonmetals are negative, which also starts with an N. So just remember the three N's. Nonmetals get a name change and they're negative. So we see the nitride is a 3- charge. It got a name change from nitrogen to nitride. And so we name this thing sodium nitride. So with all type 1s, it works basically the same way. You don't have to tell how many sodiums there are. We don't say trisodium nitride. It's always 3 sodiums with nitride. So you can leave that out. Type 2 nomenclature rules are basically for any transition element, whether it's transition, intertransition, and even some of the elements near the staircase, the metals near the staircase. A lot of these metals have ions with multiple charges. So for example, we have copper. With copper, we have a copper 1, which you notice has a symbol of Cu with a plus. You can also see a 1 in front of the plus or behind the plus, but that would denote that it's copper 1. Copper 1 in this case means copper with a 1 plus charge. If we look at this example, we now have copper 2, and you'll notice the 2 plus charge on copper 2, so the 2 plus is shown with a Roman numeral. So we use Roman numerals in type 2 nomenclature to denote or to show the charge on the metal. Copper has 2 types, a 1 and a 2, and it's very important to know which one you're dealing with when writing the different types of compounds formulas. So we see this name here of copper 1 oxide. And copper 1 oxide, if we were going to write the formula for that, I look up copper on the periodic table. It's not CO. You want to make sure to look it up. Copper is Cu. The oxide is O. And so with copper 1, remember that is a 1 plus charge. So I'll just write a plus up there to help remind me that that's got a 1 positive. The oxide, when you look at its location on the periodic table, is a 2 minus. Now, if we kept a running score of the negative versus the positive side, right now we have +1 on the positive side and -2 on the negative side. Well, it's again not even, and so we need to get a +2 on the positive side. So if I throw a 2 in there, that's 2 times the 1, which is a total of +2. Over here, again, we don't write the 1, but just to show that it's there, we have 1 times -2, which would be a total of -2 on the right side, the anion side. And so our overall formula would be Cu2O. With another example here, we now have copper 2 oxide, and you see that there. And copper 2 oxide, we have the Cu again. Now we have a 2 plus, that's what the 2 means. And with the oxide, we have a -2. This one, you have these guys canceling each other out. So a +2 and a -2 will simply add up to be 0. So this is a 1-to-1 ratio, and it's a really easy one to write. Then it would just be CuO. So with type 2s, you got to find the Roman numeral to write the formula, because the Roman numeral gives away the charge. If we're going the other way on the type 2s, now we have the formula, and if I ask you for the name, you got to figure out the name of this guy. Well, iron is a transition metal, and iron has more than one type. And so iron in actuality has a +2 or a +3, and so we got to figure out which is which. So I look at the oxide again. Oxide's a -2. There's one of them. There's also one Fe. Well, if it's a 1-to-1 ratio, the metal, the cation, has to have a charge that is equal but opposite to -2. So in that case, it would be a 2 plus charge. So when I go to write this out, I look up Fe on the table. It's iron. I make sure it's got an iron with a +2 charge, so that would be iron 2. And it's combined with oxygen as an anion, which means oxygen gets changed to oxide. Now we look at this one and we have Fe2O3. This is the other type of iron. And so again, I start out with the oxygen because I know that oxide has a -2 charge. If I, again, split these guys on negative and positive, the anion, which is the negative ion, there's 3 of them times a -2, which would give me a total charge on the right side of -6. To get that on the left side, the cation side, I've got 2 irons. If I put a +3, 2 times +3 is a 6 plus charge. So these guys would add up to 0, which means it would be neutral. Well, once I figure out that that's iron with a 3 plus charge, I can write its name. So if you're again asked to write the name, you got to figure out the charge of the cation, the metal. So this would be iron 3. Again, it's oxide. The number of oxides is not necessary to write down, so we write down iron 3 oxide. So again, with the type 2s, Roman numerals, figure out the symbol, figure out the charge, and then write it out with the Roman numerals showing which charge you found. In this case it's 3, in this case it's 2. Polyatomic ions are a lot of fun. For Honors Chem and AP Chem, there are many that you really should know, but you don't have to memorize a lot of stuff on this as we talked about in class. So we're going to review how to get this with the stealth bomber method. So let me bring up a periodic table and show you that. Okay, so we're going to zoom in here on the table, and you can see that we've got our nonmetals over here on that side of the staircase to look at. Polyatomic ions are molecules with a charge. So when we say that, we mean nonmetal compounds with a charge that form molecules. So the stealth bomber, again, it takes the shape of the actual airplane by looking at it top down. And you can see that, and the staircase forms the back of the plane, which has that look to it when you look at a real stealth bomber. We break this up into areas, and so up here I'll outline this in blue. We've got this group of 3 boxes here. We've got another group of 3 boxes here. And then in red I'll put the box of 4. Okay. So the stealth bomber is a very helpful way to remember the 8s. Okay, so we're talking about guys that end in ATE. These 3 have a 3-box pattern, and that 3-box pattern shows that they end with 3 oxygens. So we have this guy, and this guy. All of those are 8, so we've got nitrate, carbonate, and borate. Charge-wise, they increase on these from -1 to -2 to -3, and that's just a pattern you're going to have to remember. There's no way around it. And so I'll show that in the formula with a -1, a -2, and a -3. Okay, then we'll look at the box of 3 that's here. We'll redraw that. And there we've got also 3 boxes. And so each of those guys will have 3 oxygens. So we'll write out ClO3, which is chlorate, BrO3, which is bromate, and IO3, which is iodate. Okay. Now these guys, the rest of the ones that we'll look at, we go with the charge above, like we talked about earlier. So these guys all have a -1 charge. So we'll just throw that in there, and that gives me the 3 8s for the halogen family. So their charges match what they would be if they were by themselves. Okay. Okay, then we'll look at the box of 4. The box of 4 has phosphorus, arsenic, and selenium in it, and these guys would all form polyatomic ions with 4 oxygens. So we have PO4, SO4, AS, oops, that's a lowercase s, O4, and SeO4. So selenate, arsenate, sulfate, and phosphate. Now charge-wise, again, I use these, so we've got -2 there, -3 for these areas. So the sulfate is a -2, so that'd be a -2 charge. Same thing with the selenium and oxygen, selenate. And then phosphate would be a 3 minus, and the arsenate would be a 3 minus because they're in that area. Now, I'll be honest, the two you really should know for Honors Chem and AP Chem are these two, phosphate and sulfate. These two you don't see as much, but it helps with the pattern, okay, for that. So here we have ClO3 minus, which we just figured out was chlorate. So chlorate is ClO3 minus. Now, I use the chlorine one because there's 4 different types of chlorine-based polyatomic ions, and one of them, the first one we should know, is chlorate. Well, if you see ClO2 minus, that ClO2 minus that you see popping up there, that would be called chlorite. So notice the ending changes. So when you have chlorate, it's 3 oxygens for the chlorine one. Okay, not all 8s are 3 oxygens. Sulfate has 4, but the 8 would be our standard. Okay, if we look at ite, that is 1 less oxygen than 8. If you see ClO minus, now we're looking at 1 less oxygen than chlorite. So this would be called hypochlorite. So the hypo denotes that it is 1 less oxygen than the ite. So I'll just write that here to help you remember. The last one that shows up here is ClO4 minus. Now this is 1 more oxygen than chlorate. So this would be called perchlorate, and the per means 1 more oxygen than whatever the 8 has. So chlorate is 3 O's, per means 1 more, so it would be ClO4. Finally, there's some that you just can't figure out by looking at a periodic table or doing what we just talked about. You just flat out have to memorize them, and those are things like cyanide, hydroxide, which is OH minus, ammonium, which is our only positive polyatomic ion. There's no way around it. You've got to know some of these. So make sure to get that list that I've given you guys. Take a good look at it. Make flashcards if you need to for these guys because they're a little tougher to figure out. And they're really not something you can figure out by looking at the table. You're going to have to memorize some of them. So I hope this was some help for you. If not, keep coming in and see me at lunch or after school. And I'll see you later.